So we were discussing. Uh, I told you कि SN1 reaction जो है it's in two steps और SN2 जो reaction है it's in one step. और I told you the reason कि why SN1 reaction occurs in two steps. So basically, tertiary halogenoalkane is going to give, like you can say, basically there were three alkyl groups attached. So alkyl group is a bulky group which is showing steric hindrance, that is also known as resistance. So due to resistance, the coming nucleophile cannot attack. The coming nucleophile cannot attack. So that's the reason. First of all, this nucleophile have to remove from here, then the coming nucleophile will attack on the same carbon atom. So that's why we can say K, like this reaction would happen in two steps basically. Okay. Or I told you regarding the transition state, that what is transition state? Transition state basically is highly unstable, because in this state carbon has made five bonds. That's impossible. You know, that's impossible. Carbon cannot make more than four bonds. Carbon cannot make more than four bonds. So, and also we did two graphical representations, in which the first graph is showing SN2 mechanism and the second graph is showing SN1 mechanism. Okay, and I told you okay, activation energy is higher, like the first activation energy is higher for the first step is in SN1 mechanism, since the bond were breaking down and the bond breaking is difficult, so that's why more energy is required. And I told you regarding hydrolysis of halogenoalkane. So you must know the factors of hydrolysis. You must know the factors of hydrolysis. Factors means, let's suppose I have CF bond, I have CBr bond, I have Ci bond, like carbon is bonded to iodine, then carbon is bonded to bromine, then carbon is bonded to chlorine. So which bond is easier to break? Which bond is easier to break? That's the main question. Which bond is easy to break? So it depends on the length of the bond, you know. It depends on the length of the bond. It depends on the length of the bond, you know. आयोडीन का जो साइज है इट्स ग्रेटर देन क्लोरीन ब्रोमीन, एंड जो ब्रोमीन का साइज है इट्स ग्रेटर देन लाइक क्लोरीन. क्यों? कि प्रोटॉन नंबर इज गोइंग टू इंक्रीज ड्यू टू इंक्रीज इन द प्रोटॉन नंबर, due to increase in the proton number, so the size of an element is going to increase. So factors. So basically, there are two factors on which the hydrolysis depends. Number one, the length of the carbon and halogen bond, and another factor is you can say the type of halogenoalkane. We discussed there are three types of halogenoalkanes: primary halogenoalkane, then we discussed secondary halogenoalkane, and then we have discussed the tertiary halogenoalkane. Okay, so rate of hydrolysis is higher for tertiary halogenoalkane. Rate of hydrolysis is higher for tertiary halogenoalkane, and rate of hydrolysis is lower for primary halogenoalkane. Okay, क्योंकि I told you tertiary halogenoalkane is more stable. You know, tertiary halogenoalkane is more stable. Why? Because three alkyl groups are attached, and alkyl groups are electron donating groups. Alkyl groups are electron donating groups. So since the central carbon is having partial positive charge, so it has to be balanced by the negative ions. So the three alkyl groups would be donating their electrons. Okay, the three alkyl groups would be donating three electrons, and like then ultimate I can say tertiary halogenoalkane would be having the higher rate of hydrolysis. So factors of hydrolysis. Factors of hydrolysis. So number one, we have two factors. Number one, type of carbon and halogen bond, type of carbon and halogen bond, and another one is nature of nature of halogenoalkane. Nature of halogenoalkane. Like I mean to say, okay, whether it's 3 degree, whether it's 2 degree, and whether it's 1 degree. So it depends on the like the nature of halogenoalkane. Okay, so basically, the stronger, the stronger the carbon and halogen bond, the stronger the carbon and halogen bond. So the speed of or I can say the rate of hydrolysis. I can say the rate of hydrolysis is lower. The rate of hydrolysis is lower. And the and the weaker weaker the carbon and halogen bond, so the rate of hydrolysis is higher. So the rate of hydrolysis is higher. Okay, simple concept है बिल्कुल. अच्छा, then then uh then this is the first one, or I can say k rate of hydrolysis, rate of hydrolysis of 3 degree haloalkane is faster, or you can say higher. ओके, और अकॉर्डिंगली के 2 डिग्री का उससे कम होगा और फिर 1 डिग्री का उससे भी कम होगा. अच्छा, why this is so? You know why this is so? If you can see the data booklet, if you can see the bond energy, if you can see the bond energy, so look at this. Okay, these are the bond energies. Uh, yes. So see this carbon and chlorine. Then you can see carbon and bromine. Then you can see carbon and iodine. Okay, these are the bond energies, right? So you can see कि bond energy जो कार्बन और आयोडीन की है, it's lower. कार्बन और आयोडीन की जो bond energy है, it's lower. Why? Because the size of iodine is greater. Because the size of iodine is greater, so the bond can be easily broken down. The bond can be easily broken down. So that's the reason the rate of reaction would be higher. That's the reason the rate of reaction would be higher. So number one thing is that के कार्बन एंड क्लोरीन का बॉन्ड, देन कार्बन एंड ब्रोमीन का बॉन्ड, and then carbon or iodine का bond. So as we go down, so bond energy decreases. Bond energy decreases. Okay? तो इसलिए that's the reason the rate of hydrolysis is going to increase. ओके जी, तो अब ये बात आपको लाजमी पता होनी चाहिए. सेट हो गया जी? ओके हो गया. चलें. ओके, then we have formation of amine. Then we have for formation of amine. Then we have formation of amine. Let's suppose starting compound is we have haloalkane. Starting compound is haloalkane, like carbon. Then I have another carbon, and then chlorine is attached with this carbon. Then this is hydrogen, this is another hydrogen, this is another hydrogen, this is another hydrogen, and this is another hydrogen. Means that this is your uh, primary halogenoalkane. Like this is 1 degree, this is 1 degree haloalkane. Okay. Or you know that 1 degree haloalkane is going to give you कौन सा mechanism? SN2 mechanism है ना, SN2 mechanism. So I'm going to add ammonia. I'm going to add ammonia in this plus NH3 plus NH3 और कौन सा NH3? कौन सा NH3? Basically we have
In ethanol.
aqueous NH3. Or you can say if you want to do if you want to do nucleophilic reaction with NH2, so you can use ammonia in ethanol. And if you want to substitute this chlorine by OH, so you can you can take ammonia aqueous. So right now I want to substitute this chlorine by NH2. So I'm supposed to take ammonia in ethanol. Ammonia in ethanol, like this is you can say Okay. So I was saying कि if you're using in ethanol, so this product can be produced. This product can be produced like NH2. Okay, this product can be produced. This is ethanamine. Like Cl is substituted by NH2. Cl is substituted by NH2 and the rest of the product would be hydrogen chloride, and this is steamy fumes. This is steamy fumes. Okay, and if you are going to do this reaction, so you have to provide heat under reflux. You have to provide heat under reflux. So that's the reaction. Okay. So let's suppose I am going to take tertiary halogenoalkane. I am going to take tertiary halogenoalkane rather than the primary halogenoalkane. So that would be just like that. CH3, then CH3, then CH3, or this would be Cl, okay, or same reaction, ammonia in ethanol, ammonia in ethanol, and again I am providing the same condition, heat under reflux, heat under reflux, heat under reflux. So you will see that K CH3 CH3 and then NH2 or again HCl will be produced. Okay, HCl will be produced. As you know that this one is tertiary halogenoalkane. So tertiary haloalkane, तो ये आपको कौन सा मैकेनिज्म देगा? SN1 reaction. SN1 mechanism. तो मैंने आपको बता दिया था कि क्यों देगा. ओके, सो द थर्ड रिएक्शन. सो अच्छा, दूसरा ये कि what if I am using ammonia aqueous. What if I am using ammonia aqueous? So see this. What if I am using ammonia aqueous? What if I am using ammonia aqueous? Okay. Rather than in ethanol, I am using ammonia aqueous. Same reaction would happen, but you will see alcohol. You will see alcohol, and an inorganic product would remain the same. That is HCl. That's the difference between ammonia in ethanol and ammonia aqueous. Or, or I can say, okay, what if I am using concentrated ammonia? What if I am using concentrated ammonia? I am using concentrated ammonia aqueous and heat under reflux. So again, the same product would be produced like amine. Okay, again amine would be produced. That's the reason. सही है. अच्छा, बाकी then we can have the formation of nitrile. These all are nucleophilic substitution reactions. We can form formation of nitrile. Formation of nitrile. Okay, nitrile बोले तो cyanide, the same thing. So reactant is same. ओके, रिएक्टेंट इज सेम, मैं प्राइमरी ले रहा हूँ सबसे पहले। ओके, reactant is the same, that is this chloroethane, chloroethane, methane or ethane you can take. It's going to react with, it's going to react with uh, Cn minus. It's going to react with Cn minus with one lone pair on the carbon atom. और again heat under reflux सारी चीजें वही होंगी। तो I will see के chlorine is substituted by nitrile group, that is this. Chlorine is substituted by nitrile group, that is this. सही है। और or the Cl would be removed in the form of Cl minus. This is also known as nucleophilic substitution reaction. So what is the reagent and condition for this reaction? Reagent and condition for this reaction. तो याद रखिएगा कि reagent and condition. Reagent and condition for this reaction is NaCN, NaCN or slash you can take KCN like group 1 nitrile, group 1 के cyanide हैं, in ethanol. Again I am saying you have to take in ethanol or heat under reflux. और हीट अंडर रिफ्लक्स। ओके, तो जैसे कि OH रिप्लेस हो रहा है, जैसे कि NH2 रिप्लेस हो रहा है, तो सेम गोज विद नाइट्राइल। देयर इज नो डिफरेंस बिटवीन दीज रिएक्शंस, just like you can say the mechanism is the same, but the elements are going to change, the number of atoms are going to change, the number of ions are going to change basically. Okay, तो ये जो मेरे पास बना है, this is ethane nitrile, this is ethane, ethane nitrile. Okay, अच्छा, then we can do hydrolysis for the nitrile. We can do hydrolysis. So hydrolysis of hydrolysis of nitrile. Hydrolysis of nitrile. What is hydrolysis? What is hydrolysis? Hydrolysis means that when your substance is going to do a reaction, like you can say with water basically. Okay, so uh, let's suppose I'm taking, first of all we have acidic hydrolysis. First of all we have acidic hydrolysis. You know, water is must, but acid is used as a catalyst in acidic hydrolysis. If you remember in IGCSE, you used to discuss esters. You know, esters are produced by alcohols and carboxylic acids. So we can reverse the reaction. We can produce alcohols and carboxylic acid by the hydrolysis of esters. Same goes with the nitrile. Same goes with the nitrile. तो मेरा जो nitrile है, that is this ethane nitrile. That is ethane nitrile जो मैंने ऊपर बनाया है। तो मैं करूंगा क्या, जरा देखिएगा। दिस इज CH3CH2CN और this is dilute acid, this is dilute HCl aqueous, dilute HCl aqueous basically. Okay, और हम क्या कर रहे हैं, we are providing heat. So what would happen, you will see KCH3, CH2 and carboxylic acid would be produced. So if you are going to do acidic hydrolysis for the nitrile, so you will see carboxylic acid or अगर आप इसकी करते हो बेसिक हाइड्रोलिसिस, like again going to have water I'm going to have water, but rather than acid I am going to use base. Rather than acid I am going to use base. तो बिल्कुल सेम प्रोडक्ट बनेगी, बिल्कुल सेम रिएक्शन होगा, जस्ट लाइक दिस, ओके। और rather than dilute HCl I am going to take dilute sodium hydroxide, dilute sodium hydroxide। तो बजाय इसके कि मेरे पास कार्बोक्सिलिक एसिड बने, क्या बन जाएगा उसका सॉल्ट। सो दिस इज द salt of carboxylic acid. This is the salt of carboxylic acid. Why? Because I'm going to use NaOH. Because I'm going to use NaOH. You know, once the carboxylic acid is produced, since you are going to use sodium hydroxide, so there would be an acid-base reaction. So that's the reason the salt is going to be produced. So there are two types of hydrolysis. One is acidic hydrolysis, another one is basic hydrolysis. सही है, तो ये तो बिल्कुल स्ट्रेट अवे इक्वेशन है, इसमें तो कोई वो नहीं है। देयर इज नो यू कैन से कि इसका आप मैकेनिज्म लिखो, नो, यू नीड टू जस्ट मेमोराइज nucleophilic substitution reaction, okay? Then we have elimination reaction as well, you know, we have elimination reaction, elimination reaction नाम से अंदाजा हो रहा है कि इसमें यू आर गोइंग टू रिमूव समथिंग एल्स। उसमें क्या हो रहा था, द सब्सटेंस इज गोइंग टू बी सब्सटीट्यूटेड बाय अनदर सब्सटेंस। इसमें क्या होगा, यू आर गोइंग टू रिमूव समथिंग एल्स, यू नो। तो टू डू एलिमिनेशन रिएक्शन we have to take any halogenoalkane. I am going to take chloroethane again. It's the simple one. क्लोरोईथेन अगेन, ओके। इसको जरा गौर से देखिएगा भाई। दिस इज फ्लोरीन, दिस इज हाइड्रोजन, और दिस इज माय हाइड्रोजन, ओके। और let's do reaction with sodium hydroxide in ethanol. Sodium hydroxide in ethanol, you know, it would show a chemical reaction. It would show a chemical reaction. So Na NaCl would be produced, or H2O, or I can say H2O would be produced, सही है, और से सुनिएगा जरा। And along with this होता ये है कि this sodium and this chlorine, okay, or this OH and this H। तो अल्टीमेटली मेरे पास क्या बचेगा, this hydrogen is left, this carbon is left, this hydrogen is left, this bond, this carbon is left, then again I have hydrogen, then again I have hydrogen। तो क्या करें, अल्टीमेटली द डबल बॉन्ड वुड बी देयर, द डबल बॉन्ड वुड बी देयर। सो बेसिकली यू हैव प्रोड्यूस्ड alkene, basically you have produced alkene. Since HCl is removed, so to eliminate this acid you need to do a reaction with base. Therefore I have taken sodium hydroxide. So sodium hydroxide has done a chemical reaction with hydrochloric acid. Since the hydrochloric acid is removed, so I have like I got an alkene. This is an elimination reaction. Okay, so it's very simple, it's very simple। okay, हो गया जी, तो बहुत आसान है ये। And then let's suppose for elimination, this is important point, for elimination Beta hydrogen is must. Beta hydrogen must be there. Beta hydrogen must be there. अब बीटा हाइड्रोजन क्या आ गया ये सो सुनिएगा जरा. uh, भाई I'm going to give you this reaction. Let's see कि मेरे पास है कार्बन. ओके. और this is your Cl. अच्छा. Then I have this is hydrogen. This is also hydrogen. But this is CH3, CH3 and CH3. Okay. So I am removing this chlorine. I am removing this chlorine. Okay. To make it simple, I am attaching chlorine over there. So bhai, this is your alpha carbon. This is your beta carbon. The carbon which is attached directly to the halogen is called alpha carbon, and the neighbor of the alpha carbon is the beta carbon. You can see there is no hydrogen on the beta carbon. All are carbon, all are alkyl groups. There is no hydrogen. How can I remove HCl? How can I remove HCl? There is no hydrogen on adjacent carbon. There is no hydrogen on adjacent carbon. So you cannot do elimination reaction. So you cannot do elimination reaction. सही है जी. तो इसलिए हम आपको कह रहे हैं कि फॉर एलिमिनेशन बीटा हाइड्रोजन मस्ट बी देयर. बीटा हाइड्रोजन मस्ट बी देयर. तो एलिमिनेशन इज नॉट पॉसिबल. एलिमिनेशन इज नॉट पॉसिबल. बिल्कुल सिंपल है. बिल्कुल सिंपल. वेरी सिंपल. एंड आफ्टरवर्ड्स uh, he would be asking the use of some like halogenoalkane. He would be asking some uses for halogenoalkane. Halogenoalkanes are used as a solvent sometimes, and they are sometimes as a raw materials for the polymers like PVC. If you remember, polyvinyl chloride, in which the chlorine was there. If you remember in IGCSE or O levels. So they are used to make polymers, or you can also say they are also used in CFCs. They are also used in CFCs, chlorofluorocarbon, the gas which is used in the refrigerators and air conditioners. Okay. So then, like in your syllabus, you must know, okay, what is the use of CFC and what are the properties of CFC and what is the disadvantage of CFC and what is the solution of CFC. These are the things that we need to know basically. So, आइए जरा, let's discuss the uses of haloalkanes. Uses of haloalkanes. Uses of haloalkanes. So number one मैं कह सकता हूँ कि use as raw material to make PVC, polyvinyl chloride. That is a polymer. Another use, you can say, used as a solvent. Used as a solvent, right? Or used in CFCs. Used in CFCs. That is chlorofluorocarbon. CFC बोले तो chlorofluorocarbon. तो ये इनके uses हैं. You're not supposed to like go into the detail ke how they are going to use that solvent and how we can make a polymer from them or matlab that's it. That's more than enough. So in MCQ or in theoretical portion, sometime you would be asking, so you must know ke what are the uses. Okay. दूसरा ये कि what is the use of CFC? You know, what is the use of CFC and what is the property of CFC? You know, this is an inert gas. This is inert gas and this is less toxic gas, okay, odorless, tasteless, just like carbon monoxide. If you remember, when we were discussing like combustion reaction, so I told you that in complete combustion, carbon monoxide is produced, which is toxic, which is colorless and odorless gas. Or you know, CFC is also the non-flammable gas, or it's used in refrigerators, and also it's used as a cleaning agent, or you can say it's used as a fire retardants. Okay. So how many uses of you can say CFCs? So like why do we consider that this is not a good gas? Why? What are the disadvantages of like CFCs? So you know कि इसका एक बड़ा मसला है CFC का, वो क्या है कि CFC जो है it remain in upper atmosphere for a long time. You know, CFC जो होती है upper atmosphere में काफी देर तक जो है वो remain करती है, retain करती है, और ultimately when it would be present in an upper atmosphere, so the UV light would strike. So the UV light would strike on CFCs. So you will see that there would be homolytic fission. You know, homolytic fission, the breaking down of bond homolytically. You can say like the breaking down of bond symmetrically. तो वो मैं बताता हूँ कैसे होगा. तो CFC is going to deplete ozone layer. You know, the one and only reason is the CFC. That's the disadvantage of CFC. So we have to discuss that in terms of like equations, how it's gonna break down the ozone and what would be the product. As a result of this, what would be the product? So first of all, uh, this CFC, let me tell you के disadvantage क्या होंगे. Disadvantages of disadvantages of CFCs. Disadvantages of CFCs. नंबर वन के जो CFC होती है आपकी remain, or I can say retain for a long time, retain for a long time in upper atmosphere, ओके. तो उससे क्या होगा कि इन ट्रोपोस्फेयर, यू नो, इन ट्रोपोस्फेयर इसका जो बॉन्ड होता है वो बेसिकली ब्रेक डाउन होता है. ओके. तो इन ट्रोपोस्फेयर होता क्या है, इन ट्रोपोस्फेयर you can say कि bond will break down, bond will break down homolytically, homolytically
एक मिनट रुकिएगा, थोड़ा सा नेट का कनेक्शन का इशू है, 1 मिनट।
Oh my God. Very sorry for today. I don't know okay what's happening with the Wi-Fi. So okay, recording is so much disturbed. Okay. So in troposphere, I was saying okay, the bond will break down homolytically in the presence of UV light. So as a result of this, I have this chlorofluorocarbon, that is this. I have this chlorofluorocarbon. When the UV light strikes on this bond, so it's going to break down homolytically in this manner. It's going to break down homolytically in this manner. See this? Producing chlorine radical. Producing chlorine radical. The thing is that कि यही bond क्यों टूट रहा है? Why not this? This is the main question. So I would say that the carbon and fluorine ka bond is having the higher bond energy. So the UV light is not gonna break down this bond. That's the reason, okay? So this chlorine radical, once the chlorine radical is produced, so the chain reaction would be started. It would react with ozone in upper atmosphere. It would react with ozone in upper atmosphere, or as a result of this, वो करेगा क्या? It would produce ClO radical, or again it would be producing oxygen gas, and this radical, that is ClO radical, will further react with the oxygen radical. So it would be producing O2 and then Cl2. So when I'm going to add these two equations, तो ClO से ClO cancel, okay, और दूसरा ये के Cl dot, okay, plus O3 plus O dot, it would be giving us 2O2 and then Cl2, okay, 2O2 and then Cl2. Finally, I can say okay, your ozone is converted into oxygen. तो इस तरह से तुम्हारे ओजोन को इसने बर्बाद कर दिया. Overall reaction is saying that कि CFC is responsible to break down the ozone का bond. तो अगर CFC ना होता तो ultimately O3 couldn't be converting into like the O2. So CFC is responsible for this. So then what can I do? Which gas should I fill in the refrigerators in air conditions? So we have some alternatives. We can use hydrofluorocarbon. We can use hydrofluorocarbon. So we have some alternatives. We have some alternatives. So number one is HFCs. HFCs बोले तो hydrofluorocarbon. And then we can use LPG, that is liquid petroleum gas. And then uh, it's hydro and then fluorocarbon. देखो फ्लोरो इसमें भी है, बट द थिंग इज के फ्लोरीन वाला बॉन्ड तो ब्रेक डाउन होता ही नहीं है. only the carbon and chlorine bond is going to break down. So there is no chlorine in this. So we can use as an alternative. We can use as an alternative. And this LPG is liquid petroleum gas. This LPG is liquid petroleum gas. So these are the alternatives that you can use. सही है जी, okay? अच्छा. Then after the ozone depletion, I can say कि ozone ozone layer ozone layer is finally depleted. Ozone layer is finally depleted. So, like, what are the effects after the ozone depletion? What are the effects? I can say it would cause skin cancer क्योंकि यूवी रेडिएशंस आएंगी आपके पास, स्किन कैंसर, और यू कैन से ब्लाइंडनेस. ये बड़ी डेंजरस डिजीजेस हैं, ब्लाइंडनेस. और आई कैन से इम्यूनिटी लेवल इज गोइंग टू डिक्रीज. आई कैन से लो इम्यूनिटी. I can say low immunity once the ozone layer is depleted. So get ready for these diseases. तो हमें करना ये है कि we are not supposed to use any chlorofluorocarbon. So nowadays you can see the refrigerators in which they are going to use new technology. You will see a sticker over there. Okay, it's CFC free. It's CFC free. So you are supposed to buy them basically. So in that refrigerators, they are going to use HFCs rather than CFCs. Okay, that's all for this chapter. This is halogenoalkane. सही है जी.